Okay, moving on to the third dot point. This topic is such a break compared to redox, but anyway. We'll go on to talk about how you can use collision theory to describe the effects of different factors on reaction rate. We actually only going to look at these three today: surface area, concentration, and pressure. Okay, so if you go back to collision theory, essentially if you're increasing the rate of a reaction, you are increasing the frequency of having successful collisions because a reaction is essentially a successful collision. So if I can increase the frequency that a successful collision is taking place, I am increasing the rate of a reaction. So if you think about collision theory, these are the three conditions. The first one is the reactants must collide, and then the reactants must collide with the correct orientation. So how do we improve the accuracy of orientation? That's actually quite hard. Like you can't actually go there and tell the reactants, oh, make sure you collide this way, not the other way. So the only way to improve the likelihood that you're going to have a correct orientation is if you increase the frequency of collision. So if more collisions are taking place, there is a high chance that you have more correct orientation. The third requirement of collision theory is reactants must collide with enough energy to overcome the activation energy barrier. So if you want to improve this, there are two things that you can do. You either increase the energy of the collision, so if they collide far harder, obviously, it's a higher chance that that amount of energy is sufficient to break the bonds into reactants, or you can lower the activation energy barrier. So if the energy requirement is lowered, that will also increase the proportion of reactants that can meet the activation energy barrier. But we'll talk about energy more in the next lesson, not today. So we're just going to focus on correct orientation and frequency of collision, really. Make sure you use the correct terminology. You need to use the term frequency, otherwise your explanation it's going to be well, maybe incorrect. So it depends on what word you use. Just use the correct word. It's the frequency of collision that you're increasing, not necessarily the amount of collision overall. So there you go. Okay, so in order to increase the frequency of collision, you either increase the surface area if the substance is a solid, or increase the concentration if you have a solution, or you can increase, this is still concentration, but if you have a gas, then you normally increase the concentration by increasing the pressure. You also can increase the temperature. That's going to increase the frequency of collisions because particles will move faster at higher temperatures. So there are four ways to increase frequency of collision. Temperature would apply to any reaction mixture, but the other three, just make sure you look at the reaction to know the states of the reactants before you make a recommendation. Okay, this is going to be very easy for you. You don't actually have to worry too much about this diagram. It basically tells you that if you have a solid, then it's really only the reactants, the atoms on the surface that get to react. So if you increase surface area to volume ratio, you're going to have more atoms that can react. Okay. Anyway, so I'm just going to give you the actual wording. So if you increase surface area, then you will expose atoms that are previously unexposed, therefore increases the number of atoms that can be involved in the reaction. This is the textbook wording. If you do that, you're going to increase the frequency of collision between the reactants, therefore increasing the likelihood of having collision with correct orientation, and that will increase reaction rate. So I know this is really easy, but when you have to explain why the rate of reaction increases with increasing surface area using collision theory, you need to link your explanation back to the specific requirement of collision theory that is being improved here. So you can't just say, if you just say this increase reaction rate, you're not going to get the explanation mark. So some key terms need to be ticked off, and it is really easy. So I'm sure you can do it. Is that the frequency of collision increases and there is a higher chance that the collision will have the correct orientation, because this method doesn't affect the amount of energy that the collision are having. It's just the correct orientation that you're trying to address here. Similarly, when you look at concentration, it also it is the exact same explanation. It will increase frequency of collision if you increase the concentration, and that will increase the likelihood of having correct orientation and the reaction rate. This is one way to increase concentrations. You basically add more particles into the reaction mixture. So obviously flask, this go 1, 2, and 3. Obviously flask 3 has a higher concentration than number 2, which itself has a higher concentration than number 1. I do, however, want to point out that this is not the only way to increase concentration. You could also, another way to increase concentration is you could reduce the volume in the flask. Oh God, okay. You know what? I can't even. Okay, that's a little bit better. So let's say if we reduce the volume and then we have 5 particles still, that's another way, which is actually used more often because if you reduce the volume, you haven't changed the amount of reactants that you use. So this is when you want to increase reaction rate without changing the amount of product. So increase concentration by reducing volume. Okay, so that's concentration. Similarly for gas, you can do the same thing. So you can increase the concentration of a gas reactant, and you can do this by increasing the pressure, the partial pressure of the gas. So either you add more gas particles or you reduce the volume of the container. And then we have the exact same explanation. Again, this increases the frequency of collision. Therefore, there's a higher chance that the collision will have the correct orientation and increases reaction rate. So this is by increasing pressure. So you reduce the volume here, and that's going to increase the concentration of the gas particles. I do want to point out, I know I posed it as a question, but I don't have anyone to ask here, that if you add a noble gas, like an inert gas, say for example, helium, or you can add other inert gases such as nitrogen, in this case is being used, adding an inert gas doesn't increase the partial pressure of your reactant. So let's say this is the gas reactant and this is the inert gas. Just because you add the inert gas, even though the total pressure has increased from 0.1 atmospheric pressure to 0.8, the partial pressure of the gas reactant is still 0.1. So by adding an inert gas in this case, you actually haven't increased the reaction rate at all. I know there are a lot more collisions, but a lot of these collisions will be unsuccessful because they will be collisions between the gas reactant and the inert gas. So you don't want to do this. You don't want to add an inert gas as a way to increase the rate of reaction. Okay, so that the pressure of the gas reactant doesn't change. It'd be very interesting if gas law comes back around right about now. But anyway, that is it for this video.